Hi everyone, just wanted to take a minute to talk about graphing systems of equations that include absolute value functions. As you can see here, we have a system of equations where the first equation, or the first function, is an absolute value function, and the second one is a linear function. So before we actually graph that one, let's just kind of look at a couple of the possibilities we could get if we are graphing an absolute value function and a linear function. So here's my any old absolute value function, and let's look at a couple different scenarios. So we could end up in the scenario where we have a line that goes through like that, where we have 2 points of intersection. And that would kind of be one that you'd be looking for because you want to know if there's multiple points of intersection. So that way you don't just solve it once and be done with it. You could end up in a scenario where there's only 1 point of intersection. It could cross pretty much at any point on the graph. That being said, you just have to be careful that it doesn't eventually cross up here. Obviously, this one is never going to cross up here because if we were to extend this side, it would cross down here. So just be careful with the single points of intersection. You could end up in a scenario where 1/2 of the absolute value function, such as this one, is exactly on top of one of the lines. And therefore, you'd have infinitely many solutions from the vertex on. And the other side of the vertex and the other direction, there would be no points of intersection. However, you still would have infinitely many solutions because this side is going on forever. And then finally, the last one we could look at would be if we ended up in a scenario where my line looked like this. At no point is this line ever going to intersect this original absolute value function. So we could end up in a scenario where there's 0, 1, 2, or infinitely many. All right, now let's actually look at this particular problem and make sure we can graph it correctly and then find out what its point of intersection are, or if there are any at all. So if we first look at this, for those that recall, the absolute value functions in general, the absolute value of is f of x is equal to a times the absolute value of x minus h plus k. Now, a will determine whether or not it opens up or down, and it additionally will determine the steepness of the V, so to speak. If you have a really big A, you would end up with a very, very pushed together V in your graph because it's increasing really quickly. You can kind of think of it as the slope. Same thing would go if you had like a really negative one, such as negative, 10 or negative 100 or something like that. It would be upside down, but still have that very pushed together V. And then if you had a really small A, it'd be very wide. All right, and then HK would be the vertex. So luckily on this one, the absolute value function has an A of 1. So in this case, my A is 1. So it's just going to be the general parent function. So for every 1 up over 1, up 1 to the right one, up 1 to the right one, and then the other side, up 1 to the left one, up 1 to the left one. But now we need to get the vertex to know where to start from. So we know h, remember the original general form is minus h, so it's minus 2, so we would have a 2. So h is 2, and my k, that one's a little bit easier to pick up, is 1. So we'd start over at 2, up 1, that's my vertex. And as I said, because a is 1, we're treating this like the slope, so it's up 1 to the right one, up 1 to the right one, up 1 to the right one. All right, and there's that half. And then we would do the same thing on the other side, except we'd go up 1 to the left one, up 1 to the left one. And we're doing that because absolute value functions are reflected across the line x equals h. Whoa, sorry. across this line right here where the vertex is. So we would then go up like that. Okay. So let's look at another case. Let's look at the other line, I should say. Now we can start at our y-intercept of 3. You can already tell where y is 3. We're going to have a point of intersection. And then we are going to use our slope of down 1 to the right 3. Down 1 to the 1, 2, 3. And we actually have already found our other point of intersection. So we're going to graph that line. Now, we can see from our graph, we have points of intersection right here. And if that was drawn well, right there. So we have a point of intersection at 0, 3. And our other point of intersection was over here at 3, 2. And that is how you solve a system of equations involving inequalities. If you have any questions, please let me know. And I look forward to working with you on this.